Hello and welcome back to another math lesson. Just to review what we've gone over so far, we've gone over adding and subtracting polynomials, which is pretty much just putting things together, a more sophisticated way of combining like terms. We've gone over multiplying polynomials by multiplying exponents and coefficients, and now we're going to factor. So we did the riddles to kind of prepare you for factoring, which is pretty much when we take things apart. Rather than putting things together, we're going to be taking stuff apart by factoring out the GCF and, of course, using our riddles that I showed you in the previous video. Today's lesson is going to be factoring trinomials. We're going to be dealing with when our leading coefficient is 1 or when our leading term is x squared. Let's go over some vocabulary before we get started. So vocabulary you need to know. This right here is a trinomial. There's 3 pieces to it. There's a leading term, middle term, and a last term. Leading, middle, and last. I'll be referring to these by their name for the rest of the lessons. Okay, so factoring is just breaking up a polynomial. Before we go into this, which should look familiar on how we multiplied polynomials, we're going to use our riddle. Okay, I've labeled it middle for the top number and leading times last for the bottom number. First thing we want to do is identify what is our middle term. Our middle term for this example problem is 16x. So put that there. Our leading times our last is going to be multiplying these two together, which is just going to be 60x squared. Now, just like the riddle, we're going to find two numbers that multiply to get us 60, add to get us 16. First of all, let's deal with the variables. We know that x times x is going to get us x squared, and by combining like terms, we'll be adding x's. So what numbers come to mind that multiply to get you 60, but add to get you 16? 6 and 10, right. So we're going to be placing these in our boxes, 6 and x and 10x. It doesn't really matter if I place them there or if I place them there. It doesn't really matter. But we're going to leave them there for just now. We'll put our leading term here, our last term there. And remember in about 2 videos ago we were going over factoring out the GCF. We're going to be doing that today. So for these two terms, what do you notice they have in common? They have an x in common. Great. What about these two terms? What are they both a multiple of? What number could I divide out of both of these? 6. You're right. How about these two? What do these two have in common? Next, great. And what are these two a multiple of? 10. So we've successfully factored this right here. We factored out, let me just kind of use the pointer. We've factored out this into 2 pieces. X plus 10, which is right here, and x plus 6, which is right there. Let's continue, shall we? You can really see it. Again, we'll place our middle term right here. Our leading times our last is just going to be 24x squared. What are the two numbers that you can think of? Multiply to get you 24, but add to get you 10. X times x is x squared, by the way. 6 times 4 will get us 24, and 6 plus 4 gets us 10. So again, you can place them here, or you can place them the way around. It doesn't really matter. Let's go ahead and put our leader and our last term. Again, we're going to be factoring out the GCF. What do these two have in common? X. What about these two? What are they both a multiple of? 4. What do these two have in common? X. And what are these both a multiple of? What could I divide out of 6 and 24? So again, you see I have factored this polynomial into 2 pieces. x plus 6, and x plus 4. Just breaking things apart. Just break apart. Again, let's try this one. Middle term, 7x. Our leading times our last, 12x squared. What two numbers can you think of? Multiply to get us 12, add to get us 7. 3 and 4. Good job. All right, let's go ahead and put these in our boxes. Remember, it doesn't matter where the 3x goes or the 4x goes. All right, let's place in our leading term, our last term. And by the way, the leading and the last term just come from here. Leader, last. All right. So what do these two have in common? An x. Good. What are these both a multiple of? What could I divide out of 3 and 12? 3. What do these two have in common? And what are these both a multiple of? So I've successfully, again, broken apart this polynomial into these two pieces, x plus 3 and x plus 4. Let's try a few more. Again, if at any time, please just pause me and try a couple problems out on your own. I'm going to show you the answer either way. We can do this even when there's just different variables. So our middle term is 6y. Our last times our first, or our leading times our last is y squared. What two numbers can you think of that multiply to get us 8, add to get us 6? 2 times 4, great. Well, again, let's put this in our boxes. Doesn't matter if the 2y goes here or if it goes here. Let's put our leading term and our last term. What do these two have in common? Y. What about these two? What could I divide out of 2 and 8? 2, great. What do these two have in common? Y. And these two. What do these two have a multiple in common? What could I divide out of 4 and 8? Awesome, great. So we've we've factored this polynomial into two pieces, y plus 2 and y plus 4. It's kind of like multiplying polynomials, only we're going backwards. Let's try another one. Ooh, there's those negatives. Let's see if we can still figure this out. So again, I'm going to start with my middle term, negative 10x, leading times my last, 16x squared. Now again, try and find two numbers that multiply to get us 16, but add to get us negative 10. Negative 2 and negative 8. Now negative 2 times negative 8 is positive 16, and 2 negatives and 8 negatives combine to be negative 10. Remember, it doesn't really matter where they go. We'll put our leading term in the leading box, last term. What do these two have in common? Next, what multiple do these two have in common? An 8. What do these two have in common? An x. And what multiple do they share? Now comes the question of where I should put the negative. Okay. Should I put the negative at the 2 or the 8 or both? I should put it at both. And here's why. A negative 2 times a negative 16, negative 2 times a negative 8 will get me a positive 16, right? Whereas a negative 2 times a positive x will get me a negative 2. A negative 8 times a positive x will get me a negative 8. So my two binomials are x minus 8 and x minus 2. Let's try another one. Again, I'm going to put my middle term, negative 5x, my leading times my last. What two numbers multiply to get us a positive 6 but add to get us a negative 5? Negative 2 and negative 3. Again, it doesn't matter where we put them. We're going to put our leader and our last term. Again, what do these two have in common? X. What about these two? What multiple do they share? Both are multiple of 2. What do these two have in common? X. And what are these both a multiple of? Both are a multiple of 3. So now we're going to decide where to put the negative. Should I put the negative on the 2? Should I put the negative on the 3? Or should I put it on both? Both. So the negative 3 times the negative 2 will get me a positive 6. So my binomials are x minus 2 and x minus 3. Let's try another integer one. Our middle term is 7x. Our leading times our last is negative 18x squared. What two numbers that you can think of multiply to get me negative 18, but add to get me 7? Negative 2 and positive 9. Remember, it doesn't matter where these go. We'll put our leading and our last. What do these two have in common? What about these two? What are they a multiple of? What do these two have in common? And what are these both a multiple of? Again, my question is, where should I put the negative? Should I put it at the 9, at the 2, or both? I should put it at the 2 only. Here's why. If I put it here, I'll get a negative 2x, and if I put it here, I'll also get a negative 18. You'll also see they both have a negative in common. So I have factored this polynomial into two binomials, x plus 9 and x minus 2. Go ahead and try this next one out on your own. And I'll go ahead and show you the result afterwards. Now they're both negative. So again, if you need to, make sure you're listing out your multiples. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Remember, these are negative, so you could either have that be a negative or backwards. In this case, it's 3 and negative 8. I'll place these in. Doesn't matter where. I'll find my GCF for these two, my GCF for these two, my GCF for these two, and my GCF for these two. Where should the negative go? You're right, on the negative 8. So my binomials are 8 take away 8, x take away 8, x plus 3. As always, happy problem solving. See you later.